Hi guys, so we're going to pick up with solving inequalities that contain rational expressions. So looking at number one here, what we want to do, just like we did with the polynomial inequalities, is to get this to 0 on the one side. So in order to do that, we're going to subtract 3. And when we do that, we get 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. Now, don't think that you can cross multiply this up here like it's a proportion, because we cannot do that with the inequalities, so don't get confused about that. So once I have this, what I need to do is I need to find a common denominator so that I can go ahead and subtract this. That's the only way I can put this and simplify the left side. So again, this is over 1, if you think about it that way. So the common denominator here is going to be x minus 5. So really all I need to do is correct for this, because the x minus 5 is already in this first fraction. So by doing that, I have my first fraction minus, now I have to multiply the top and the bottom by the x minus 5 so that I get it as an equivalent fraction. So all I did was multiply the top and bottom by the common denominator. So now I can write this as one fraction, so it's 2x minus 7 minus 3 times x minus 5 all over common denominator is less than or equal to 0. So let's go ahead and simplify the top here so we can distribute. So it gives me minus 3x plus 15 all over x minus 5. And then that just leaves me with negative x plus 8 over x minus 5 is less than or equal to 0. All right, so now if you know anything about the graphs of rational expressions or rational equations, what you will find out is the numerator gives us a certain piece of information and the denominator gives us a certain piece of information. So the numerator here, this, I find some room, will give us all the x-intercepts when you set it equal to 0 and solve for it. And then the denominator will give you the vertical asymptotes. So when you set the bottom equal to 0 and solve for it, it'll give you any vertical asymptote that you have. So by doing that, I have for the x-intercept, up a little bit, I have negative x plus 8 is equal to 0. So that gives me, for the x-intercept, negative x is equal to negative 8, so x is equal to 8. So that gives me my x-intercept, and for my vertical asymptote, x minus 5 is equal to 0, so x is equal to 5. So that is where I will have my vertical asymptote. So let me put those on the graph so we can see that. So we have the 8 is going to cross, it's the x-intercept, and then I have a vertical asymptote at 5. And I'm going to use a highlighter to show this. I'm going to go a little finer on the point tip there. So at 5, let's see if I can get this to be straight. Pretty close. So you can see here that this, what I just did, the x equals 5, is where the graph will approach but not cross. It's going to approach those values of vertical asymptote because it's undefined there. And then it is going to cross at x equals 8. So now if you were to go ahead and graph this, you will see that the graph looks like this roughly. See, it's approaching that asymptote, and then here, and it goes down and below. So this is pretty close to what the graph looks like. Well, what is it that we want? We want it to be less than or equal to 0. Just fix that point again here. So we want less than or equal to 0. Well, that means that we want below the x-axis. So where is the graph below the x-axis? Well, that's going to happen here. And then it actually happens here. So you got to be careful. See, if you have this intercept at 8, as you're coming back down, it's going to cross over the x-axis at 8 and keep going. So let's do a number line chart. That'll help us out a lot. This is all the way negative infinity, and this is all the way to infinity. And this over here is negative infinity. And then we have 5, and then we have 8, which is a closed circle, or including the value there. And that's pretty much it. So let's go ahead and put our sign chart here. So from negative infinity all the way up to this vertical asymptote, which is at 5, this graph is below the x-axis, so it's negative. From 5, the vertical asymptote, all the way to 8, it's above. And then from 8 all the way to infinity, it is below. So we already said that we wanted where it is below. So we want these two intervals right here. And I didn't put my infinity symbol here, sorry about that. That's actually not the best infinity symbol. So we want those two intervals right there. So the actual answer for this would be parentheses negative infinity all the way to 5. Parentheses, because you cannot include a vertical asymptote, it's undefined. So you will not have a bracket there, even though it is a less than or equal to. Union, bracket, 8 to infinity. Now we can have a bracket around the 8 because that is an x-intercept. That is a defined point, so that's okay. So this would be the final answer for that particular problem. So let's go ahead and take a look at another one. So you can see we have this right here. Now it's already set to 0, so we can just go ahead and take a look at your numerator and your denominator to get some information. Remember, the numerator here is going to give us the x-intercept, and then a denominator is going to give us the vertical asymptotes. So when we solve, so our x-intercept here is equal to 0, so x is equal to 3. And then for our vertical asymptote, we have x squared minus x minus 2 is equal to 0. So that is factorable, which is good. So we get x minus 2 times x plus 1 is equal to 0. So we get x is equal to 2, and x is equal to negative 1. So these two are our vertical asymptotes. So let me go back and switch and get my highlighter for the vertical asymptotes. So we have vertical asymptote at negative 1. So see how straight I can get that. 1, and then at 2. See how we get that one. Pretty close. It's close enough. And then it crosses at 3. Right here. All right. So when we take a look at this graph, what you're going to see is it looks something like this. And then in between the two asymptotes, the graph goes like this, roughly. And then the graph comes from here and crosses over and goes like that. So that is the graph of this particular rational inequality. So what is it that we want? So again, we want where it is less than or equal to 0. So we want below or on the x-axis, below or on the x-axis. So where is that going to happen? Again, below or on the x-axis. So this right here, that is where it's below. And then it's also below from here to here. So those two intervals. Now, this definitely helps to do a sign chart for your intervals because this graph definitely looks confusing. So let's go ahead and do that number line chart. Remember, this side is all the way negative infinity. We got negative 1, then we have 2, then we have 3, and then we have infinity. Sometimes it helps, I didn't do it in the other problem, but sometimes it might help to go ahead and highlight your asymptotes so you know you cannot include those values. So let's see what we got. So from negative infinity to negative 1, we are below. From negative 1 to 2, we're above. From 2 to 3, this little piece right here between the 2 and the 3, where it crosses the x-axis, that is below. And then from 3 all the way to infinity, it is above. So of course we want to know where it's below, so we want this, and we want this right here. So that means it's this interval, and then it's this interval is what we want. So writing that, and again, be careful with asymptotes, we're going from negative infinity all the way to negative 1 parentheses, because it is a vertical asymptote, it's undefined. And then from 2 parentheses, because it's a vertical asymptote, it's not defined, all the way to 3 bracket, because that is an x-intercept that is defined. So this is our final answer for that problem. So this finishes up the this particular section. We did the polynomial behavior, polynomial inequalities, and then we did this last video, which would inequalities that include the rational expressions. So hopefully this helped, and I will see you on the next video.